This is for those of you that are going to necessarily want to go quickly through things and use your calculator and put in your brains the fact that at this point, if you're not using lists, you've just made a decision you don't want to use lists. Figure out a way to do it quickly, but understanding a lot of this is about efficiency as well. So if you've got a determinant here, which is the x and y and no z of the radial vector and the x and the y of no z of the force, you need to hold place with zeros. How does this determinant turn out? It's a cross product. You put it in your calculator and lists for rx, y, rx, ry, rz, fx, fy, fz, and then have the calculator do calculations. You should be able to program that yourself, but it's programmed already. So it is basically a cross product. And I'm going to show you down here on Wolfram Alpha is the same thing. So I'll just plug in 1 right now. Remember, you use stat if you would, or you learn to do things like store into a list. But in this case, stat works pretty good. You got a minus 7.68. That, of course, is the radial vector from whatever you're calling your origin, and this is a plus 20. Remember, you then have to hold place. 0. Go to the right here. F of x is 0. I'm sorry. RZ, I'm going to go back because it's probably, and I'm going to hit an enter here. You have minus 6.7, 7.6800. F of x is 3.96. Have to hit an enter here. F of y is minus 13. And f of z is 0. That is all of the moment for that first one. I'll do one more, and then we'll do, well, I won't do one more. I'm going to do it down below here. I'm going to hit here and say second quit. I'm just going to go ahead and do a program AA list 2. And we'll see what it turns out. You got an error mismatch, and why that occurred is, in fact, the length of our matrices were not the right length because I had done some editing. So if you hit second quit here, you go back in your program, but basically AA list makes things the right length, and it doesn't change what you've got in there, which is kind of interesting. I thought it doesn't reinitialize. So when you hit second quit here and go to program AA list 2, realize it's written for you, but you can write this. It's not a big deal, and that's what you end up with. So let's look what it looks like in Wolfram Alpha. You see, usually if you've done Wolfram Alpha in the past, it basically is a cross product, and you can do it any number of ways. You're trying to get tied into the Mathematica, if you would. Thinking of that Ms. Flannery, minus 7.68, and competing against her on a playing field that has been connected by wires. In other words, you can outsource a lot of civil engineering. Hate to say it, but a lot of the design can go overseas. So we've got to learn to do it better and more efficiently. 3.96 minus 13.06 and then 0. Notice in this case you've got to put the 3 components like you do very often in a 3D engine. Close the bracket here with a hard bracket. And that should come up with the same answer that we got here as we push through that. So I'm going to hit equals, and then I'm going to take you down through the answer. 21.10, and so if I hit here, enter, and I then go to program (21.86, 21.10). Probably had something to do with something I keyed in. 6.8. Let's see what we got here for inputs. They should be exactly the same. 7.68, 20, 3.96, minus 13.06. Let's see what we had here. Stat, edit. Minus 27.68, 20, 0, 3.96, minus 13. There's your error. Once again, duplication, 13.06, though I'm going to point out you really need to then check that your variables are getting cleared on this. Second quit, I don't think they necessarily are. Clear, program, A list 2, and then second program I'm sorry, second quit, program, AAV list 3, and there you have the 21.10 that you saw down in the calculation here. So, same stuff. This is a pretty nice way to write these out because it actually right on your structure. So then as you go ahead and change your radial vectors, you can kind of cross things out. My analogy, I guess, for this, and I'll put one out, is remembering, yeah, RREF is great, Kramer's rule is great. Can you physically remember how to multiply matrices and how to do Kramer's rule to solve systems of equations? That idea of picking and replacing columns and then doing calculations of the determinants of that value and the determinant of the main to get your solutions. So I'm going to publish this, and that's kind of your last tool, if you think about it, where it makes it very quick to calculate what's in front of you, which is important, but it's also important that you've got to be able to calculate quickly and efficiently, especially in 3 dimensions, which this was not, but which we held that place in the reality that 7th graders have Inventor in their hands, and they will be competing with our jobs, for our jobs. Hate to say it, it's just true. Thanks for listening.